Welcome to our comprehensive guide on Java interview questions, covering everything from basic concepts to advanced topics. Today, you'll master 6 essential areas that every Java developer should know. First, object-oriented programming concepts including encapsulation, inheritance, polymorphism, and abstraction. Second, the Java collections framework with ArrayList, LinkedList, and HashSet implementations. Third, multithreading concepts for concurrent programming. Fourth, Java virtual machine internals including memory management and garbage collection. Fifth, the Spring framework with dependency injection and aspect-oriented programming. Finally, common design patterns like Singleton, Observer, and factory patterns. These topics form the foundation of most Java technical interviews. Object-oriented programming, or OOP, is built on 4 fundamental pillars that every Java developer must understand. Let's start with encapsulation, which is the practice of bundling data and methods together while controlling access through visibility modifiers like private, protected, and public. This ensures data hiding and maintains the integrity of your objects. Next is inheritance, a powerful mechanism that allows you to create new classes based on existing ones. This promotes code reuse and establishes hierarchical relationships between classes. The extends keyword in Java enables a child class to inherit properties and methods from its parent class, creating an ISA relationship. The remaining 2 pillars of object-oriented programming are equally important. Polymorphism allows objects of different types to respond to the same interface in different ways. This means you can have multiple implementations of the same method, and the correct version gets called at runtime based on the actual object type. Method overriding and method overloading are 2 common examples of polymorphism in Java. Abstraction is the process of hiding complex implementation details while exposing only the essential features to the user. Abstract classes and interfaces in Java provide abstraction by defining contracts that concrete classes must follow. These 4 concepts work together to create maintainable, flexible, and reusable code. Here's a practical example of inheritance in action. The animal class serves as the parent or base class with a protected name field and a public eat method. The protected access modifier allows subclasses to access the name field directly. The dog class extends the animal class using the extends keyword, automatically inheriting all non-private members from the animal class. This means every dog object has access to the name field and the eat method without having to redefine them. Additionally, the dog class adds its own specific behavior with the bark method. This demonstrates the power of inheritance code reuse and the ability to build specialized classes on top of general ones. The Java Collections framework provides a unified architecture for storing and manipulating groups of objects. 3 of the most commonly used collections are ArrayList, LinkedList, and HashSet. ArrayList implements the list interface and uses a dynamic array internally. It's excellent for scenarios where you need fast random access to elements and frequent read operations. LinkedList also implements the list interface, but uses a doubly linked list structure internally. It excels in scenarios requiring frequent insertions and deletions, especially at the beginning or middle of the list. HashSet implements the set interface and ensures no duplicate elements are stored. It uses hashing for fast lookups and is perfect when you need unique elements with fast search operations. Understanding when to use ArrayList versus LinkedList is crucial for writing efficient Java code. ArrayList uses a dynamic array implementation where elements are stored in contiguous memory locations. Adding elements has O(1) amortized time complexity, meaning it's constant time on average. ArrayList provides fast random access to elements and has better memory efficiency due to less overhead per element. It's the better choice for frequent read operations and when you need to access elements by index. LinkedList uses a doubly linked list where each node contains data and references to the next and previous nodes. While adding elements is O(1), LinkedList excels at insertions and deletions anywhere in the list. However, it requires more memory per element due to storing additional pointers. Multithreading enables concurrent execution of multiple parts of a program, improving performance and responsiveness. Java provides robust support for multithreading through two main approaches. First is thread creation, which can be accomplished by extending the thread class or implementing the Runnable interface. The Runnable interface is generally preferred as it provides better flexibility and follows good object-oriented design principles. Second is synchronization, which is essential when multiple threads access shared resources. Without proper synchronization, you may encounter race conditions, data corruption, and unpredictable behavior. Java provides the synchronized keyword for methods and blocks to ensure thread safety. Here's how to create threads using the Runnable interface, which is the recommended approach. The MyTask class implements the Runnable interface and overrides the run method. The run method contains the code that will be executed when the thread starts. In this example, the thread prints numbers from 0 to 4. To actually execute this code in a separate thread, you create a thread object and pass an instance of MyTask to its constructor. Finally, calling the start method begins thread execution. The Runnable interface approach is preferred because it allows your class to extend other classes if needed, and it separates the task logic from thread management, following the single responsibility principle. The Java Virtual Machine, or JVM, is the runtime environment that executes Java bytecode. Understanding JVM internals is crucial for performance optimization and troubleshooting. The class loader subsystem is responsible for loading class files into memory and managing class hierarchies. It follows a delegation model and ensures classes are loaded only when needed. Memory areas include several regions. The heap stores object instances and arrays. The stack stores method call frames and local variables. The method area stores class-level information, and the program counter keeps track of the currently executing instruction. Garbage collection is the automatic memory management system that reclaims memory occupied by objects that are no longer reachable, preventing memory leaks. The Spring Framework is a comprehensive platform for building enterprise Java applications. Three core concepts define Spring's approach to application development. Dependency injection is Spring's implementation of inversion of control, where the framework manages object dependencies rather than objects creating their own dependencies. This promotes loose coupling and makes testing easier. The Spring container automatically wires dependencies based on configuration, reducing boilerplate code significantly. Aspect-oriented programming, or AOP, handles cross-cutting concerns like logging, security, and transaction management. Instead of scattering this code throughout your business logic, AOP allows you to define these concerns separately and apply them declaratively. Spring Boot provides auto-configuration and opinionated defaults, enabling rapid application development with minimal setup. Design patterns are reusable solutions to commonly occurring problems in software design. Three fundamental patterns every Java developer should know are Singleton, Observer, and Factory patterns. The Singleton pattern is a creational pattern that ensures only one instance of a class exists throughout the application lifecycle. It's commonly used for database connections, logging, and configuration management. However, be careful with thread safety when implementing Singleton. The observer pattern is a behavioral pattern that defines a one-to-many dependency between objects. When one object changes state, all dependent objects are notified automatically. This pattern is widely used in event handling systems and model view controller architectures. The factory pattern is another creational pattern that creates objects without specifying their exact classes, promoting flexibility and loose coupling. Congratulations on completing this comprehensive journey through essential Java interview concepts. You've covered the 4 pillars of object-oriented programming, explored the collections framework with ArrayList and LinkedList comparisons, understood multithreading fundamentals, delved into JVM internals, learned about Spring Framework concepts, and discovered important design patterns. These topics form the backbone of most Java technical interviews. Remember, consistent practice is key to mastering these concepts. Code examples, understand the underlying principles, and be prepared to explain not just how things work, but why they work that way. With this solid foundation, you're well equipped to tackle any Java interview with confidence. Good luck on your interview journey.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.